Now we're going to talk about perfect cubes and non-perfect cubes. And we're going to do this using these examples. Here's the first example. Is the number under the cube root symbol a perfect cube or non-perfect cube? To determine this, you can use your knowledge. You have memorized the perfect cubes up to 7 times 7 times 7, or you can type this into a calculator. If the result is an integer, the number under the cube root is a perfect cube. If the result has a decimal, then the number under the cube root is a non-perfect cube. So I'm going to start by, well, I've already clicked perfect cube for this one because I hope you remember that 8 is a perfect cube. But I do want to just really quick review the perfect cubes with you to make sure you remember them. So 0 times 0 times 0 is 0, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, or you could say 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, or 5 times 5 times 5 is 125, 6 cubed is 216, 7 cubed, or 7 times 7 times 7 is 343. I think I even taught you that 8 times 8 times 8 is 512. You really have to just go up to 7 times 7 times 7. That's what the standard says that you have to know up to, have it memorized. And now I wanted to highlight the fact that 8 is a perfect cube, just like negative 8 would be a perfect cube. But we can also check on our calculator, and we can type in, you use this symbol, and you have to put a 3 up here, and then we type the 8 here, and since we get an integer 2, the answer is only 2, not negative 2. With the cube roots, there's only one answer. With the square roots, there's 2 answers. So with the cube root of 8, since we got 2, that the result is an integer. So 8, we confirmed, is a perfect cube. Alright, so that's a perfect cube. Correct answer, perfect cube. Great, we did a good job. Is the number under the cube root a perfect cube or non-perfect cube? So 25. Okay, now this one, I made it to be a little bit tricky because 25 is a perfect square. But is 25 a perfect cube? Well, if we look back at our list, 25 falls between the perfect cubes 8 and 27. 25 is not a perfect cube. 25 is a perfect square. It's not a perfect cube. And let me prove it to you by typing it into the calculator. The cubed root, so I type a 3 here, of 25. Oops, didn't mean to do that. I need to go under the cube root. 25. Look, we get a number that has a decimal. And this decimal expansion, you're going to have to trust me, goes on forever, and there's no pattern. So if you take the cube root of a non-perfect cube, the decimal expansion goes on forever and has no pattern. So this is a non-perfect cube, and I got that right. I already submitted this so that I could look back at the answers to check my work. So non-perfect cube. All right, the cube root of negative 70. Well, let's look at our list. Is 70 on our list? And it's not. 70 falls between the perfect cubes 64 and 125. So 70 is not a perfect cube. But let's type it in to the calculator. So the cube root of negative 70, and you'll see it gives you a number with a decimal. So negative 70 is not a perfect cube. So that's a non-perfect cube. Good, and we got it right. Is the number under the cube root symbol a perfect cube or a non-perfect cube? Okay, so the cube root of 168, let's look back at our list. 168 is not on our list. So we're going to say it's a non-perfect cube, but we're also going to check our work using the calculator. The cubed root of 168. So the cubed root of 168. Look, we do not get an integer. An integer doesn't have a decimal expansion like this. This number has a decimal expansion that goes on forever and has no pattern. So that is a non-perfect cube. And then the cubed root of negative 343. Well, look, 343 is on our list. And I could have also made all of these negative. I hope you remember from the notes we took the other day on perfect cubes that you can also, multiply negative 7 times negative 7 times negative 7, and you'll get negative 343. So down here, negative 343 is a perfect cube. To check our work, we type in the cubed root of negative 343, and you get -7, which is an integer. So if the result is a negative, that's fine as long as it's an integer, so we don't have a decimal that goes on forever and has no pattern afterwards. I think that was the last problem. So in summary, if you take the cubed root of a number and you get an integer, it's a perfect cube. The number here is a perfect cube. If you take the cubed root of it, this number, and you get a number that has a decimal expansion, then this is a non-perfect cube. The other way you can think of it is an integer times an integer times an integer is what gives you a perfect cube. A number that has a decimal expansion times a number with a decimal expansion times the same number with a decimal expansion will give you the non-perfect cube.